Hello, everyone. Welcome back to the continuation of our previous lessons. Please, if you have not watched our previous lessons, do well to watch it for a better understanding of this concept I'm about to do now. Now, this is the determination of a particular element in a compound, which is oxidation number determination. So we're not going to waste time, so we can start. Now, please, for those of you who have not subscribed, do well to subscribe, like, and always comment the next topic that you are finding challenging on the comment section. When I see it, I respond immediately. Now, let us start with this simple question. Now, the question says, determine the oxidation number of sulfur in sodium thiosulfate. It's a very simple question. Now, we'll do solution here. Now, take note, it's simple. We have Na2S2O3. Now, take note, this is a compound, and this full compound here is equal to 0. Why is it equal to 0? Because there is no charge here. Let me erase this. There is no charge here. This compound is different from this radical or polyatomic radical. See now. So that in this case here, this total atom here is equal to this charge. But in this case here, there is no charge. So you first of all say it's equal to what now? 0. Now, I am looking for sulfur here in this compound. Now, take note, sodium belongs to group 1 element, and all group 1 elements have a valency of +1 in a compound. All group 1 elements in a compound have the valency of +1. Meaning, if I'm having sodium, lithium, potassium, cesium, rubidium, they are all group 1 elements, and their valency or charge is just +1. So here is sodium is +1. +1 times 2, +1, because you have to multiply by this 2 here, which is the subscript, right? So 2 times sodium, which is charge of which is +1. 2 times 1 is 2 plus. I am looking for sulfur here, and you're having 2 sulfur here, 2 atoms of sulfur. That become 2x. Now take note, I've told you before that oxygen in a compound always have an oxidation number of -2, right? Which is -2. So -2 times 3 here is negative what now? 6 equal to 0. Now, mathematics, here becomes, let me do it here, here becomes 2x is now equal to, I'll move these ones to this other side. So -6 will cross and return to 6. Of course, +2 here will cross and return to -2. So here become 2x is equal to what now? 4. So sulfur here is now equal to what now? +2. I hope I have not lost you here. Take note, I'm looking for 2x. Normal mathematics, I'm looking for sulfur here. So -6 we cross this equality sign, +2 we cross this equality sign. There are several ways to do it. So if you can understand this concept, this one is easier to understand. Can I go on? Okay, so take a snap of it before we move to question 2. Now, the next one we have to work on is determine the oxidation number of iodine in potassium iodate or potassium triiodide. We do not know whether it is +2, +3, +4. That is why we have to determine the oxidation number of it. So let's go. So again, here become this. Now take note. Step 1. This full compound will be equal to the charge, and the charge here is 0 because there is no charge here. So it is a compound. Compound always have no charge. Okay. Now I'm looking for iodine here. Remember, I've told you before that potassium is a group 1 element, and because it is now in a compound, it has a valency of +1. So here is 1. You only have 1 atom here. Plus, I'm looking for iodine. Oxygen has a valency of -2, which I've told you before. In all polyatomic compound, oxygen, both polyatomic compound, both binary compound, except otherwise in the case of peroxide, which is hydrogen peroxide. So my -2 times 3 is -6 equal to 0. I'm looking for iodine, which is now equal to 6 minus 1. Minus 6 cross return to plus 6. So 6 minus 1 is equal to what now? Plus 5. Now take note, that is why this compound is called potassium triiodate 5, because the oxidation number of iodine here is plus 5. Meaning, in this case here is plus 1, here is minus 5. Here is plus 5, here is minus 6, right? Potassium here is plus 1. Oxygen is minus 2 times 3, which is minus 6. So we add everything up here. It will give me equal to what now? 0. Is that clear? Do you understand it? If you do, comment below and say I understood. So let's continue to the latest version of it now. Now listen now. Be very careful of this question 3 that says determine the oxidation number of copper in this compound. This is a complex. This is a complex. It is actually very easy. I can tell you that for free. It is very, very easy. Do not be moved. Yes. Now, while we are taking our classes, we take it from the grassroots to the complex level, to the advanced level. So our students who are preparing for O-level exam can find a middle ground to become advanced. That is why you must be a certified chemist to actually be able to handle marker or to be able to teach this chemistry properly for better understanding of students. Now let's go. Now look at this one now. This is a complex compound. And in naming it here, this one is called, don't bother in naming it for the now. For those of you who are still growing in chemistry, which later in this video, I will teach you how to name complex compounds. This compound is called tetracyanocuprate. I will let you know why it is cuprate in my next video lessons. Now we do not know, so let us do it together. Now take note, there's something we call neutral molecules. Neutral molecules, examples: H2O, example NH3, example N2. All these are neutral molecules. And if they are neutral molecules, they have an oxidation number of 0. Now, we can also have cyanide, right? Have an oxidation number of -1, which is, this is how it is, cyanide. Hydroxide, -1. Ammonium, +1. So let us do it together to understand that this foundation. Take note. So how do we do it? We come here. Everything here will be equal to this charge here. Now I'm looking for copper, right? Water is a neutral molecule. So therefore, its oxidation number of it is 0. So 0 times 4 is what now? 0. Plus, now, okay, let me not say plus yet. Now, cyanide have an oxidation number of -1. Remember, I've told you, we have cyanide here, which is -1, which is -1. Hydroxide, -1. So, -1 times 4 is -4, equal to the overall net charge here, which is what now? -2. Overall, of course, this is the charge here. So, simple. Copper is now equal to -2 minus 4 cross return to +4. So +4 minus 2 will give you what now? +2. So the oxidation number of copper in this complex is +2. Is what? +2. I hope it's very easy. Now in our next video, we'll go much more deeper in other cases. I remain my humble self, Adrenaline the Bazooka Prophet. Thank you, and God bless you.